Hi guys. So if you look at this on page 356 of the textbook, you can see that when we're looking at the surface area of a rectangular prism, um, you need to think about the idea that a rectangular prism is like a box. So if you think about a tissue box or a box in some situation, we're looking at all four sides, or I'm sorry, all six sides, which are also known as faces. And so if you look at the box that is to the left, the prism that's to the left, you can see that there's one that's highlighted pink. And so the pink is considered the base here. And so you have a top and a bottom, what I like to call the top and the bottom. And then you have, looking at that figure on the left, you have a left and a right, and then you also have a front and a back. So if you're thinking about it in those terms, you can then break it down into this idea of the algebra. Since you have a front and a back, you have a left and a right, and you have a top and a bottom. You have two of each of those, which brings you to this algebra of S equals, which S is the surface area, equals 2 times length times width from the bases, the top and the bottom, plus 2 times the length times the height, plus 2 times the width times the height. Again, those bring in all six faces then of the figure. Okay? So as you're doing each of these kind of problems, you want to be able to pull it apart and kind of look at it in that fashion. All right? Um, when we do an example here in a minute, you'll get to see another way to look at it as well. So as we look at example 1 here, you can see here the way that they've done it. They've broke it down using that same formula that we saw above here, right? Okay. They also bring it down into what's called a net. So this is also one way to visualize it, which would be breaking down each side so you have the faces here laid out, okay? One way that I'm looking at this as well that I want you to think about it is this way. So I recreated it. No, it's not perfect, but it gives you the idea. So when we look at the top and the bottom, right? Here's the bottom, so we know that that's 3 by 5. So I put top and bottom is 3 by 5. Then I look at the left and the right. So over here I'm going to look on the left side. It'd be this side here, right? And then this is the right side. Okay? So this would be going this way. Since this is 5, we know that this is also 5. And then going up, the height of it is 6. So we have 6 by 5. Okay? And then when we look at the front and the back, here we have the front. A little bit easier to see there. We have it 3. And then again, we have this here where it's by 6. So we have 3 by 6. So remember, we have two. We have a top and a bottom, a left and a right, and we have a front and a back. So 3 times 5 is 15, but then it's times 2 because there's 2 of them, so that's 30, right? And then 6 times 5 is 30, and we know because we have a left and a right, we know that that 30 then is multiplied by 2, and that's 60. And then we have, here we have 18, right, for the fronts and the backs. So we have 18 times 2, which is 36, right? And so then when we add all of that together, we end up getting 126 inches squared. Okay? So that's another way to do it. All right. Looking at example 2 on page 357, you can see that now we're looking at finding the surface area of a triangular prism. So the way that this triangular prism is situated, it looks like the bases are the top and the bottom, right? Based on what we were discussing last time, which are the triangles. So for here, you would actually have to find the base, the area of the base. And so that's using the formula of the triangle, which is area equals 1/2 base times height. So with this triangle, you can see where the base is 3 and the height is 4. And so when you take half of 3 times 4, you get 6. Now notice, when you look at how they put this together, at the bottom, they put 6 plus 6. Why did they do that? They did that because you have a top and a bottom base, right? So it's 6 plus 6. Now if you look, they did color code it for you, and you can see where you have the green lateral face, which was 3 by 6, which is 18. You have the purple, which you can't see. That's where this one gets really tricky. The purple you actually can't see when you're looking at it from this angle. But it's that one that would be behind, and if you look at the little dotted line, you can see where that's going. Now, the purple, again, that's going to be that 5 times the 6, which gives you 30. And then the blue, you are able to see, that blue rectangle is 4 by 6, which gives you that 24. So when you add all of those up, you get the answer of 84, and it's 84 square meters. Hi guys, hopefully those examples were helpful for you, and that you were able to do well with the on your own problems. For the on your own problems, for number 1, you should have gotten an answer of 52 feet squared. For number 2, you should have gotten an answer of 288 meters squared. And for number 3, you should have gotten 150 meters squared. And for number 4, you should have gotten 60 centimeters squared. All right. So hopefully you were able to get those. If not, please go back and try them again. Shoot me an email if you have any questions or need any assistance. I would also like you to work on page 359, numbers 7 through 14. Okay? Give 13 and 14 and try and see what you can come up with. But definitely 7 through 12. All right? Sounds good. I'll see you later.